Right, this video is going to talk you through a model question on biological metal extraction. So the question I'm going to model is about the production of uranium. So we've got to read that information, and then it wants us to explain why uranium is produced by bioleaching more than traditional mining. So we're going to read through the question and highlight the important bit. So uranium oxide is used in nuclear reactors, around 75,000 tonnes. I'm just going to circle that because I quite like, because tons of uranium oxide is needed every year. Traditional mining methods such as underground mines and open cast mines supply around 20,000 tonnes. In traditional mining techniques, the uranium ores are crushed and pulverized into very fine fragments. Water is added to make a slurry. This is mixed with sulfuric acid. A precipitate of uranium oxide forms. This is not very pure and needs to be enriched. Okay, so because it's not very pure, that's going to need an extra stage. This process involves a lot of energy. And normally when we use lots of energy, we use fossil fuels. And we should be aware that they are non-renewable, so they're going to run out. And they also, when they're burnt to get the energy, they produce CO2, which hopefully we all know is a greenhouse gas. And because it's a greenhouse gas, that's going to increase global warming. Right, so the remaining 55,000 tonnes of uranium is extracted from low-grade ores or previously used ore. So low-grade ores, remember our definitions, are low concentration of, in this case, uranium, which means they're not cost effective with traditional methods. I'm just going to abbreviate that to trad because I know what I mean. Or previously used ore. So it's important that we can use this to extract metal from previously used ore, because that allowed us to recycle used ore, and that will, anytime we can be recycling something, we are conserving supplies. I think for uranium, it's not particularly important. I think we've got over 100 years worth of uranium stocks, but for other metals, it's more important. In bioleaching, bacteria oxidize Fe2 plus and S2 minus ions. This leads to the formation of sulfuric acid, which can then break down the uranium into soluble uranium ions. Oh, hang on, we've missed a bit here. So if we go back to the previous paragraph, large amounts of waste rock slurry are produced. So if we've got large amounts of waste, that's going to need landfill. No, you can't see that on there, but I've just written landfill at the top. Right, where were we? So explain why more uranium is produced by bioleaching than traditional mining methods. So we need to use the information in the question, but we also know something about bioleaching. So we should know, hopefully from our lessons, that bioleaching is cheaper than traditional methods. We also know it's slow, which is a disadvantage. So I'm going to put positives here, and I'm going to put negatives there. So it is slow, but slower than traditional methods. But it is, and the other disadvantage is it also produces toxic substances. However, these are outweighed by the fact that it's cheaper, and we've already said that we can use it for low-grade ores here, and those ores aren't cost effective. We can use it to recycle, which conserves supply. And also it uses the bacteria, so the bacteria is readily available and it's natural. And if we think about traditional mining, we should hopefully know some disadvantages of this, which is they're unsightly. And they also produce lots of noise. and they destroy wildlife habitats. Right, so that's all the information we need. So now we just need to put this into, remember it's a 6-mark question, so we need to write this using good quality written communication. So we need to write in full sentences. So that you don't have to watch me write out the entire thing, I'm going to stop the video there, and then I will send you a PDF of the final answer. Okay, thank you for listening.